Hello everyone, welcome to my YouTube channel Learn with @aviboy 2006.
So in today's session, we will learn about what is a Kubernetes and how it can be used in AWS. Like, and many of you have maybe heard about like the word called Kubernetes or maybe EKS, cluster, like all this word. So we just get to know that, okay, what exactly that words mean to be. Okay. So let's first uh, see like what is the actually official definition of the Kubernetes like. So Kubernetes is actually open source tool which is developed by the Google, and it actually is a container orchestration tools. Okay, when I say container orchestration tool, right, it is uh, like it combine a multiple container by through the automations and through some scalable tool. Okay, that become a easier for to the deployment process also, and even hosting purpose also. Okay, and it's purely developed by the Google, and now it's widely used by the many of the cloud service providers also. Okay, actually that is a basics things about the Kubernetes one. So what is the Kubernetes exactly? Okay, so as I mentioned, it's the open source software that allows you to deploy and manage a container application at scale. Okay, so I think you might have doubt on that. If it even if the load balancer also give a scaling option, oh, why should we to use the Kubernetes also? What is the difference between the load balancer and Kubernetes? Yes, we'll come to that point on that part, like because there are two different concepts. Okay, so what the name Kubernetes actually origins from the Greek words like meaning of the helpman or pilot kind of thing. Okay, generally it is used very widely used as the K8S, K8, like Kubernetes, as an abbreviation from the counting the 8 letter between the K and S. So Kubernetes, right? So how it so K2S to it 8 letters. That's why the K8 the abbreviate use it. So as a you can see in the slide, right? It runs in anywhere. Okay, when I say it runs anywhere, it means that it doesn't require any cloud specific also. So why it's a more differentiative, because it run on the AWS, it can run on Google, it can run on Azure, or it can run on any third party cloud provider also, or even it can run on your premises server also. So it's like it can run anywhere, wherever you put it. So it's like a one software tool or one management tool. You use it anywhere which you want to use it. That is what the benefit of the Kubernetes. Whereas if you go for AWS particular something, right, like ECS something, it can run only on ECS part or EC2. You cannot plug out and move it to the on-premises similar configuration. You have to use the AWS to use the EC2 only, or maybe if you go for other cloud provider, that they will have separate server concept. Okay, they will go for it. But in terms of Kubernetes, the different part. And as I say, it's a portable. Portable is like you can keep it anywhere. You can travel like that, and it is like plug and play, or you can plug any cloud or any offline premises servers also. Okay, it is extensible also, so it can extend and scale based on the demand, based on the availabilities also. Okay, and of course, it's the open source one. Okay, so that's about actually Kubernetes one. The way kind of any question on that? Okay. Yeah. Let's understand now why Kubernetes comes in a picture, and why what is exactly it's help us in a more in detailed way. Okay, so let's go back to the ancient time, or maybe the older time of the deployment process and how it was doing it, right? So look at the diagram. The first diagram said traditional deployment, whereas we were having hardware. Okay, and hardware is installed, and the operating system was installed on hardware, and then in app was installed on the operating system. It's like a similar one. We took a one on hard disk, we keep some RAM or CPU, and then inside the hard disk we install the operating system like Windows or Ubuntu, Linux, Center or anything, and then you configure your app on that. That was the initial traditional deployment was there. Later time it came to the virtualization mode, like cloud based. Okay, at that time how it come, hardware also was there. Okay, so hardware was the initial base layer. On top of that, operating system was there, and then someone was a hypervisor. Hypervisor is like someone who are monitoring things or like how things to be done that part. Okay, on top of that, there was a separate machines was there. So it like virtual machine was a place. So one operating system can be used by the multiple operating machines also in that way. Okay, initially what happened, we used to install different server and different operating system was there. But in virtualization, like the one operating system will be have one virtual machine on that part. Okay, and then the particular installation package or library we will install it. On top of that, the application will be installed. Okay, so there was a this came in the picture when in a cloud comes in the picture. After that also there was a things like, okay, now today we have a multiple cloud provider. Tomorrow if the cloud provider is also gone, or we somebody want to move from the one cloud provider to another cloud provider, how it will be easy, then we have to adapt to their technology. Okay, and that to solve the problems, right, the container kind of deployment comes in the picture, where you can package your installations, configurations, and OS in one container and then deploy it through that. So the operating system will be shared across the different container runtime. Like I will say, container runtime is like the things which run one operating system and which provide a different container. Okay, so it's like you have one hardware where you install the operating system, and that's shared across the multiple container. Container is like it have a source of code. It will have volumes attached to it. Volume, the hard disk attached to it for storage purpose, and it will have installation libraries also, which you have to require to run the application. Okay, so difference between virtual deployment and content deployment was right. It was the you can see the difference main in virtual deployment, like each virtual machine has their own operating system also, whereas in container deployment will not have a different container, will have not have a different operating system. It is shared across the container. That was the difference. Because of that reason, it was easy to plug and play also and put it on a different cloud service provider. Okay, and that is why the container are good way to bundle it up and run your application. Okay, and this was the problem actually solved by the Kubernetes, and that help us to a lot of the company to remove their tension. Like if I want to go on to move for the a cloud provider one to be B2C like that. Okay, so I think you understand now the why Kubernetes, like how Kubernetes help us, and what was the reason to use a Kubernetes. And it's why the another like next to X1, like as I mentioned, right, it runs the application on scale basis. Okay, and now I'll talk about load balancer. So load balancer also work based on the scaling also. It also help us to balance the load and keep an auto scaling in AWS. But that service provider is by the AWS. Okay, but if you want to use that service to the your on-premises services, you can't use the AWS services on-premises, right? There here the Kubernetes will help us to do that. That is why the Kubernetes help us to run the application at the scaling level. They have the configuration which support a scaling mechanism. Okay, and then next is seamlessly move application. It like because of the containerization, right, it can be seamlessly moved from the local development machine to production deployment machine. So in that case, our local development environment and the cloud will not have a much difference on that, because everything will be same only. We just have to push the codes and similar thing can be deployed across them. Is run anywhere. I think the previous slide I mentioned same thing as like, and add new functionality also because of the open source project, right? Adding a new functionality to Kubernetes is easy because there are various of people are working towards the community to helping and fixing the issues, adding the more functionality. Why is that? So because of that, developer companies are build extension on top of the Kubernetes integrations that help Kubernetes to use more widely. Okay, so now let's understand the inside of the Kubernetes, how exactly it work. Okay, so actually the main things will be a Kubernetes cluster. Inside a Kubernetes structure, there will be a master and there will be the worker node. Okay, so in when you're talking about the Kubernetes, people will always talk about the node concept. Node is nothing but like another virtual machine, another virtual machine. Okay, it's like a EC2 also. It can be anything else. So one will be master, one will be worker node. So master is operate everything. Okay, like it command, it communicate also like that it will work. Worker node will manage a different a container to the pod. Okay, so inside the worker node will be have a pod. Pod is the one concept. Okay, which is like it is a kind of when we say pod, right? Pod actually manage the different container. Okay, and pod work is like a do the job and then vanish it. Okay, once they finish their job, they will vanish it out. Okay, and it will available for next pod to come in the picture. Okay, so it is like and pod is a very smallest unit part of the Kubernetes part. Okay, and it store on the multiple containers. It store the like the pod can manage a one container or can manage by the two, three multiple containers. The pod is pod who the manage the container. Okay, it has own namespace to run the code. Okay, so you can simplest word you can say the pod actually the manager of the container. Okay, container who run the code, who has the capacity to store the data and have a server running on that. And on that on for that container required a manager which required a pod. Okay, in simplest word we can mention like that. Okay, so this is the basic, okay, Kubernetes cluster, and Kubernetes cluster will have an input parameter which is given by the either by JSON or YML input. I think, okay, YML is yet another markup language which I think we have learned in a cloud formation template, right? There. So Kubernetes is the push or developed by through the either by JSON format or through by the YML input. Okay, so let's understand this architecture in deeper, more deeper node. Okay, okay. So now this diagram talk about how exactly the communication from internet and communication from the deployment work in the Kubernetes architecture. Okay, so let's first focus here on the left side of the diagram first. Okay, we'll divide this diagram in a two. So let's have a this segmentation, and here the left side, and this will be the right side. Okay, so let's understand first the left side portion. This is the input which I talk about, like YML or maybe the JSON format. Okay, that will have an input to the Kubernetes master node. So master node is a major admin part of the Kubernetes. It receives the inputs via YML or JSON. Okay. Now master node consists of the three things. Sorry, not three things, four things. One is the API service. Second one is the scheduler. Third one is the controller. And fourth one is the data source. API service is an important part of the master node. So API service is actually the exposed publicly. So whatever changes you need to do to Kubernetes, it will be do by the API service. So we can mention like it's similar like a REST API, okay, which will have some authentication through IAM or authentication through other token through that. So through that API service, which we can manipulate the Kubernetes cluster, or we can create a cluster, or we can delete the cluster through the API services. Okay, and it's actually core part of the Kubernetes one. Okay, and API service always talk to the worker node and give a command to the worker node what to do. Okay, and when to active, when to go to the dev state, everything will command given by the API service. Okay, now second is the scheduler. The scheduler is actually responsible to maintain the state of the pod. Okay, So pod, saying the manager of the container, right? So scheduler decide the responsibility of the maintain the state of the pod, okay, which is running, whether it is running or not in a kubelet, okay, and waiting. I generally give a assign the worker. I suppose one pod done his job and it vanish out. Now it's job of the scheduler to get another available pod and assign it to the particular container and assign it to the worker node. That is the job of the scheduler. So it keep running. Schedule is like a keep running service. It always keep checking whether pod is active or not. If any pod is deactivated or deactivated, it will his job to do that, make another pod active available. Okay, and that is what the scaling work. So example, if you're running on the multiple two pods, okay, and one request go to one pod, job done. Suppose the request gone from the one user to the 10 requests, and requirement for the pod is become now 10. So it's scheduler job to check, okay, how much is the requirement now. I have to make the other pod to be activate. So that scaling will be handled by the scheduler part. Okay. Next is the controller. So control is actually a kind of a controlling a part, okay, where it control the volume. Okay. So it control the exact volume itself generally. Okay, and whichever the operation of worker node will be there, right? Whether the worker node is live mode or not. If any worker node goes on the day state, it has the responsibility to make that another worker node alive. Okay, so whereas schedule make a responsibility of the making a pod active, the controller makes sure that worker node should be active in terms of that. Okay, so this scheduler and controller talk to the API service, and API service manage give a command to the particular to the worker node. You can see the arrows are seeing here. The controller talk to the API service, and scheduler also talk to the API service, where API service is given that command to the worker node by the communication channel. Okay, and the fourth one is the data source. Data source is like a database kind of thing where you can store some key value information, like some configuration value. It is not to exactly the database kind of thing, but yes, we can store some of the key value store here. So it is not like that we cannot connect to the RDS, which is supported by the PostgreSQL or by MySQL. Yes, we can do it, because that is separately hosted to the any other database provider, which you can configure in your container inside the code. Okay. The job of the data source will be just to show some key value configuration, key value format configuration value it is required to be stored. Okay, so now we understood the left side of the Kubernetes. Let's understand the right side of the Kubernetes, what exactly is happening. Like, because here we understand left side is like how to deploy it, who deployed it generally. So through the YML JSON file, we just deployed the Kubernetes cluster to the API services. Now this is a worker node. As you see, this is a worker node. Inside a worker node, there is a kubelet is there and kube proxy is there. So what is a kubelet? So kubelet actually talk to the API. Okay, as you can see, API service give a command to the worker node, right? So kubelet is a job to talk to the API service and listen the command which API service is given in. And based on the command, it pass the particular information to the next level, that is a pod. Okay, and it also things like any functions via kubelet. It's like a, so if anyone of remember, right, each Linux machine or maybe which a machine will have a, or operating system will have a daemon. Okay, when you say daemon is running, right, it's man that's similar like a kubelet is also. So in kubelet architecture, a kubelet is one of the daemons only, which manage the running all running nodes. Okay, that's about the kubelet. Now next is the kube proxy. So kube proxy is a kind of thing we can say a network tool management, where it maintains the all networking configuration like incoming and outgoing traffic, and it, of course, is exposed to the internet. And that is why if you want to use any website to host or maybe API to be exposed, right, that rule will be managed by the kube proxy. So all the incoming rule, okay, which traffic to come inside and which traffic to go outside, are that purely managed by the kube proxy. A similar tool available in our AWS is like a security group where you do the incoming and outgoing rules management. Okay, So this is a Q proxy, and I think you have know, right, the pod I mentioned that similar thing, and this is a Docker runtime. So Docker runtime is required to run all the container which is managed by the pod. So pod can manage a multiple container, okay, and that has to be run through the Docker runtime. So here I'm just want to make sure that I'm not saying Docker, I'm saying a Docker runtime, which manage running the all the containers environment. Okay, so this is how exactly the Kubernetes architecture work. Okay, so it's similar like our cloud architecture only, but if you want to place this architecture in our on-premise server also, still we can like build it, because as it's required to deploy through the API, and it has export to the internet to the kube proxy, so we can use as a REST API also, we can use as a web app applications also, and it is purely run on the containerization, so it supports all type of language to run, because at the end it's a package of the particular runtime environment. Okay, so now I think we understand how Kubernetes architecture is there, right? So we'll see how it run on the AWS generally. Okay, so I think using Kubernetes, you can run any type of the containerized applications using the same toolsuit on premises and cloud. Okay, and you understand that part. So AWS also provide that. AWS also support that, because Kubernetes is an open source. So AWS has support to run the Kubernetes on his account, AWS service account also, where you can choose to manage infrastructure yourself with the Amazon EC2, or get automatically provision or manage a Kubernetes control plane with the AWS EKS. So there are different way to do it. Particular thing, either you can get the powerful or community backend integration with the AWS service like Amazon Virtual Provide VPC, IAM identify, or discovery also. So it's like there are two ways. Okay, use your Kubernetes authentication to you to push API service, push the deployment to API services in the Kubernetes, or else you can go for the VPC of AWS along with the IAM role permission. So there are two ways to authenticate. So I use that one generally. So let me just show you that the provision. So I was talking about this one. So Kubernetes can be installed using the help of the EC2 machines also, or it can be installed through the EKS. So I was talking about the EC2. So it's like we can create a fully managed Kubernetes deployment and provisions through the EC2 instance type. Okay, I'll walk through on the diagrams how it exactly work. And second was it like directly you can, AWS has a different product called EKS. Okay, that also you can use it to run the Kubernetes without needing a provision to manage a master instance or etcd one. Okay, and another one, like you can pull images from the ECR. The ECR is the Elastic Container Registry, where we keep all the Docker images. Even we also use that all the Docker registry in ECR only. So whenever we want to deploy anything, we first pull the images from the ECR, okay, and then you deploy it generally. Okay, so that also can be integrated to the Kubernetes. So let's understand on that a piece, like how we run Kubernetes on AWS EC2. So I'll just talk about first the left side of the part here first, and then we'll discuss on the EKS, how EKS work. So here you can say there are the EC2 are mentioned here, right? So here everything we will be hosted on the EC2. So like example, try to remember the diagram which I went through. There was a master node and there is a worker node. Okay. So I say, right, master node is nothing but like another virtual machine only. So I can replace that master node with the EC2 machine. So one EC2 can be a master node and other EC2 can be a worker node. Okay, in like example of current our architecture also. Okay, in that also key where the we will keep a multiple EC2 whenever the auto scaling happen through the load balancer. So we keep adding the EC2 machine whenever is required a load extra, and whenever we degrade a load, we'll keep decreasing the particular EC2 machines also. A similar thing can be used here in the Kubernetes also. So EC2 will become another node. So this orange is like a master node, which manage our controller, API service, and scheduler. You can see here. Okay. And it give a command to the proxy and the kubelet for to route the rules and manage the worker node. So this EC2 are the worker node. Okay, this EC2 are worker node, which is consists of the Docker container runtime, and it has the kube proxy. Okay, and it has a pod installed. Like one pod will be one container, some pod will be two container, some pod will be multiple container. Depend upon the load, it is manager container particular thing. Okay, and you can attach extra external EBS volume if you require the storage. Container will have other limitations on the volume, but you can attach the extra EBS volume to attach to have allocate some extra memory storage. Okay, and this network will be exposed to the route 53 to internet and load balancer pointed to the internet. So it is like we can point route 53 to this cluster, and you can point to the load balancer through also. So indirectly, like we can say this is accessible through our REST API or maybe the web app application. There are some more details inside the architecture to understand more details. We will not go into more in detail part, but just to high level, like we are replacing the master node with the another EC2. We are replacing the worker node with the another EC2. So EC2, we are using the EC2 as a virtual machine to manage the node. Okay, that's the Kubernetes run on the AWS EC2. Okay. Any question on this left side diagram? Okay. Now let's understand the right side of the diagram. Right side of the diagram talk about the running the Kubernetes with the help of the AWS EKS. Okay, so what exactly it does is it has a master node and it has a deployed a worker node through, and there is a portal called EKS also where the run the application. So here it will be like a step-by-step configuration, like click, 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 click. You provide a name of the, I'll walk through on that, how it AWS provided. You provide a name for the particular EKS cluster, and then you provide the details you require to be like which IAM role to be assigned, and then you provide what are the capacity you require to be run on the particular thing. It automatically manage everything. So in the left side, we have to talk about like, okay, which EC to use it, which instance type to use it, what will be security group will be there, it will be placed in that the VPC subnet. All this will be comes in that part. Versus when you go for EKS, that headache will not be there, because that headache will manage by purely the Kubernetes cluster only, which based on and then that provision will give to the worker node. Okay, and the particular application can be run on the this particular worker node. So let me just walk through on the AWS. Stop sharing here. So this is the Amazon console where you can search about the EKS. Once you search about EKS, we can land it to the page here. Okay. And so this was the document taken from this documentation. So here options called like add cluster. So you can register existing clusters also if you're already having another cloud provider, or you can create a new so here the pricings are mentioned based on the worker node and the pod. So I'll just click on the create cluster. Here you can mention the cluster name, suppose AWS. Yes. Here we can mention the which Kubernetes version we are to mention it. Okay, so we're talking about the upgradation of the Kubernetes cluster, right? There we have mentioning the number. So when we are going from one version to another version, so existing upgrading, like we are just upgrading the Kubernetes version on that part. Okay, so I'll just click on default version. I have created the existing IAM role, but if you don't have a created the existing IAM role, we can just go to the IAM policy here, go to the roles and click on the create role. There is a set of instruction given in the this. If you click on the info, right? If you land it to this page, it's clearly mentioned, go to the IAM, then create a role Based on the role, you click on the trusted entity type as AWS service provider, and use case will be the AWS supervisor, and choose the E key here. So the predefined one. So like click a role here, click on the AWS services. In the use case, just search for the EKS. Once you click on the EKS, there are multiple things are there. Like I am role to give the which, but we are going to create a EKS cluster. So we will select the here EKS cluster. The next here the policy will be there automatically. The one existing policy will be available. If you want to add extra rules, we can add it extra rules here also. Okay, there is some unresponsive page, but yes, this already role is created in a IAM role, so I'll use this role here, demo EKS cluster role. If you want to add a tag, you can create a tag here and give the information, which team or which application you're going to use for EKS cluster. I click on the next. Once you click on next, I have to mention the specified networking protocol by which VPC I have to use it. If I already have an existing VPC, you can create the existing default, or which can choose from create a new VPC group and define it. So this based on this selection, it automatically subnet group will be allocated. Okay, and the security group also we can use from the selected default one. Here we have to choose whether which IP version we have to use, IPv version 1, 4 or 6. I'll go for version 4. Here's the option called configure the Kubernetes service IP address fetch. So if you want to use for specific IP range, right, we want to expose this, we can use the range of the IP address. I will click on the disallowed. Now, next block is the cluster endpoint access actually. What is exactly cluster endpoint? So we were talking about API services in the master node, right? So that master node, we have to keep either the public or the private or public and private. So when you say the private, right, then we will be authenticated to service provider, maybe the AWS or maybe a Kubernetes account or any other cloud service provider. So it required then the authentication to access the particular API services, and plus that can be placed under the VPC groups also. So I don't have currently any authentications. I'll go for a public one. These are the very basics values here, like which AKS version we have to use it, build for use, and then we'll go for that version to build based on above version for the core DNS part. So DNS is like a whichever proxy I was talking about in the worker road, right? Which build we have to use to create that proxy server. There are different versions are there available for to manage a proxy server. We'll click on the next. Here we'll have options for like configure the login. So if you want to configure the login for the API services, audit, authenticator, control manager, scheduler, these are the services which is available in the master role. If I click on that particular services, so all the login mechanism will be enabled for particular services. So you can have a, okay, which deployment happened through API server, or maybe how the communications went from the scheduler to API server or control to API server, that can be done there. So next is the review and create it. So it will be reviews, like we can see the create, and then we can create it here. So it's going to be create now. Yeah, it will take some time. Let's see how much time it take. Here it is given the ECR part also, where we can store our container storage for EKS requirement, where we can pull our Docker images. Like if you are using the specific service Docker image, like running on the WordPress machine, running on e-commerce, or running on Drupal, maybe other framework related in pre-build like ArcGIS, something which you can use that particular container from the EKS part. Yeah, so that is about the creating the EKS. I think it'll take some more time.
Thank you for watching session. Don't forget to like, share and subscribe to channel.